information about two reactions is given. The neutralization reactions between citric acid and sodium hydrogen carbonate is endothermic. The displacement reactions between magnesium and carbon dioxide is exothermic. Which statement about the two reactions are correct? The energy of the products formed in the neutralization reaction is greater than the energy of the reactants. Okay, so neutralization. Neutralization refers to the first one, and they are endothermic. So let's see the energy level diagram as a revision. So this is the energy, and then this is the progressions of the reaction. Okay. Now endothermic is where the reactants absorb energy from the water, for example, and then get more energy. That is endothermic. So the energy level shows the energy of the substance, the chemical substance. So endothermic is like that. Okay. And because of that, the energy of the product is greater. True, you see the product is here. Product is here. Reactant is here. So hence, it is correct. This is correct. The energy of magnesium and carbon dioxide. So when I say magnesium and carbon dioxide, it refers to exothermic. Okay. The energy of magnesium and carbon dioxide is greater than the energy of magnesium oxide and carbon. So we need to know this as a displacement reaction, right? Is where the more reactive magnesium react with the less reactive carbon dioxide, then the more reactive will become ions and hence become magnesium oxide. It become ion at the Mg2+. The atom become ions. Then the ion here, carbon is the ion. Carbon has charge, So I mean, by the way, they are just scalar molecule. So it has oxidation number. I should say that it has oxidation number. At the end, it become zero oxidation number. Displaced. So this is the reaction of displacement. And then since they say it is exothermic, so let's do a quick revision for the energy level diagram. It has higher energy and it go down to lower energy. So this is the Mg plus CO2. This is the MgO plus C. Okay. The energy of magnesium and carbon dioxide is greater. Yeah, true, it's greater. Greater than the energy of magnesium oxide and carbon. So which is true. In an exothermic reaction, the energy required to break the bond is greater than energy required when the new bonds are formed. Okay, you see the formula. Delta H equal to bond breaking minus bond forming. Okay, so the energy required to break the bond is greater. So this is greater than the energy release when the new bonds are formed. That means this is lesser. So if you take a greater value minus with a lesser value, you will get a positive answer. You get a positive answer, which is not exothermic anymore. Exothermic is delta H equal to negative, So that's why It's not exothermic, it should be endothermic, because greater, minus, and lesser is positive answer. Positive answer is endothermic, so something wrong with number 3 already. So rejecting number 3, then of course it is B, 1 and 2. So is that okay, buddy?
Just give me a minute, sir. I just want to understand it again.
Okay.
So I still don't understand the part 3.
Part 3, okay. You see it slowly. The energy required to break the bond. This part. The energy required to break the bond, this one, is greater. So this is greater. Energy required to break the bond is greater than the energy released when the new bond are formed. That means this is greater compared to this. So they are trying to say that bond breaking is greater, bond forming is a smaller value. So imagine, let's say you have 1000 for bond breaking. Bond forming is just 200. Imagine an example. So 1000 minus 200, you get positive 800. Positive value, you get positive 800. If it is a positive value, it should be endothermic. So because of that, it is wrong, because this should not be exothermic here, it should be endothermic. In an endothermic reaction, this one is greater than this, then it is true. But when they say exothermic, then it is wrong.
Okay, sir. So basically, in an exothermic reaction, the bond forming, the energy to form a bond is greater than breaking a bond.
Yeah, correct.
Okay, sir.